Okay, so let's start. Title of this lecture is the moving from client-side render to the server-side rendering in Wix. I'm Noam. I'm an architect and one of the developers in this specific project. Wix, I work at Wix, Wix.com. I don't know if you all know us, but we have a couple of engineering locations. We're basically in Israel, but we have two sites, two large sites in Ukraine and Lithuania. Not in Poland, though. One of the services that we provide is that we provide the ability to build a website very, very easily and to manage your small or medium business in it. One of the things, like more of the cornerstones of us working is using client-side render. We built this architecture, we were very proud of it, and we lasted with it a couple of times. We had a few patches, we fixed it, we moved to React, we moved to a lot of several locations, a lot of different solutions, but we were very, very happy with it. The site was generated on the client, and it gave us like a lot of good stuff. Like, for example, it allowed us to have a very simple server architecture. You get a request, the server returns like a template, and everything, all of the client code is being downloaded. I will drill into the client-side architecture while I'll describe what changed. But the simple server architecture allowed us, it had like a very small CPU footprint on the server side. So there were no CPU-intensive tasks on the server. It required us a very small amount of servers on the back end, and it allows us to grow very, very fast, very, very quick. And when the resources was downloading slowly, we use CDN, and it gave us the ability to control the client version. This specific point, I will remember that one. We'll talk about it a little bit later. So if it worked very well, why to switch? It's like the most oldest saying in computer science: if it works, don't touch it. So why did we change? Something must have happened. So the first thing that happened is that Google was starting to threaten the drop of Ajax crawling. If you have like a site that is being dynamically built on the client, in the Google and other search engines has it's hard for them to index them. Now they threaten to remove that. We use Ajax crawling, which gives the servers, the crawlers, a different version with all of the data with it. And if Google would dump like the way that we index our sites, it would have been very, very bad for business. Another thing is that people love mobile devices for some reason, and the increase of those devices, client-side render required many resources on the client, and the mobile devices are slower, have a lot of different problems in a different way that they work, and it starts to be a support issue. So users start complaining that their mobile sites were slow. So those 2 points were very important, but I think the biggest threat was the Ajax crawling one. So at the beginning of, this is the first time I'm talking about this project publicly, and we started doing it at the beginning of 2017, and they pulled me to a room and they just tell me like, okay, now you have to replace all of the client architecture that we like so much and replace it with another thing. It's a very big thing to do, and it's also like the main business thing. So if you ruin it, it's gonna be very painful for a lot of people. I think the first tip I give to anybody who gets to a company: if you want your name known, create a downtime. After a few minutes of downtime, everybody would know your name. The only problem with this strategy is you can do it only once. So we started at the beginning of 2017. We started deploying it at May, and by the end of the year, everything was deployed. And I can wait till the the end of the presentation to show you what the effect was, but the effect was very dramatic. Most of the sites, actually these graphs are actually humble because they're not showing the client side, the mobile performance. They're showing actually the desktop performance we had later on. So in 90% of the cases, we had a drop in performance of 50%. Not drop, but an increase. So a site that was loading in 10 seconds was downloaded, was loading now in 5 seconds. So those had a very, very dramatic effects on the way that we deliver websites. So how did we do it? I think like every other task, we try to make it work. We try not to break anything, and on the way, we try not to disturb anyone or cause any interference with the way that people work right now. Remember, everything is working right now. It's not a new project, so we have to replace everything where everything keeps running. So let's go to some of the tasks that we did in order to make it work. So the first thing was to make it work. We had to make the client code, and our client code has like a couple of million lines of code, maybe 10 million lines of code, and we had to make it run on the server. So how do we do that? What are the issues that we hit? First of all, we had to adapt the client code to actually run on the server because there are some things in client that can cause a lot of problems. For example, memory leaks and implicit states. So when you're in a browser, you have just one VM. When you're in the server, you keep sharing the same VM over and over again. So implicit state is sometimes a user can, like for example, if you have an experiment system and you're randomizing one thing on the browser and the browser randomizing that value, if you do that in the server, then and you store that value, then everybody would get the same experiment. So you have to avoid things like this in the new architecture. Also, memory leaks. For example, we had someone implementing a cache, and that cache would never been cleared. And what happened is that after maybe, I don't know, an hour, the server would crash with out-of-memory exceptions. So this is everything inside of a client code and not a server one. So client folks are not very well aware of it. Also, when you move to server-side rendering, you have to have your code run both on the server and the client. So you have to fix all of the places where people are accessing DOM or don't write pure components and store state in some places. So everything needs to be pure. Another thing is that if you have a random value, for example, you're taking a timestamp or you're just randomizing some UUID, you have to have the same thing happen on the client side, because otherwise React will drop all of the work that you did on the server. So if we are randomizing or taking timestamps or taking anything on the server, we have to store it and deliver them back to the client. When the client will need that value, he won't randomize a new one. By the way, this thing was improved with React 16 that had an hydrate option that allows better flexibility with those kind of things. And I think the most significant one is the mental overload of client people. They used to write code and do a lot of things that they could do back in the day, but now their code runs on the server. So if someone does something weird, it can crash the server. And if his code performs 25% slower, then now we have to bring up 25% more servers, which cost more money. So I think the first thing that was implemented was a unit test, not a unit test, but an integration test with the server-side rendering. And every time someone broke something, then that test failed. So I had people coming to me and saying, I see this test failing. Can I still deploy? And I said, no, you have to fix it now. Because because people were not aware of us doing it at like the back end. So how did we adjust the server architecture? The server architecture was, and I'm kind of simplifying it a little bit, but basically you have a request coming to the server. It returns a template that contains all of the references to the client code with the user metadata, and everything is rendered. Afterward, we just added a simple thing. We added another renderer on the side, and the renderer would render the HTML itself and return it back to the client. So the changes in architecture were very, very simple in that sense. Some architecture would say move that to the front, move the server renderer to the front, but had we did that, that would actually make all of the traffic go through us and very endanger like production. And so this design was simple. And Node.js was probably like the first name that pops up. I checked a few other options, like, for example, Java, Rhino, and the other JavaScript engines. But Node was a perfect fit. Like VMs works very, very slowly. So if we took Node is very, very good, but it's not so good for CPU-intensive tasks. And and rendering is a CPU-intensive task. So what happens is usually when you get a request, that request is taking a CPU, and then Node is not handling another thing. I think one of the common practices that we have currently with Node servers is that we have two instances, and those two, one of them is getting the request and one of them is performing. Because even if it gets a render request and it blocks the CPU, even if you're pinging him with a health test, then it won't answer because it's doing something else. So we had to rethink it and see what we're going to do with it. So the first thing that we did is we brought up renderer cores and node one. So we have one node, one process, the first one who answers this request, gets a request, sends it to one of the multi-threaded environment that we have in Node, because it's single-threaded, and that request is rendering the HTML. Once it's finished, it returns the response to the user, and that was very good for us. But when I when I created performance testing for this, I realized that the more I got like very weird results. For example, I would have like a certain performance. I have like a quad-core machine. I'm running one rendering core. It does maybe like, I don't know, 3 requests. I would expect adding another one would do 6, but it wasn't doing 6. So the graph here, even like the red one, was actually even lower. I think it got to a point where I added more cores and the rendering speed actually decreased. So once I started analyzing it, I realized that the problem is that the operating system was working against me. It would start taking a specific node process and moving it to another core, and all of those task switches were costing me a lot of time. So I used Unix, very simple command. Apparently you can do that. In Unix, you can actually stick a process to a specific core. So if you use task set to do that, you're able to say that core number 0 will only handle that process. This was actually allowed me to do to scale the way that I wanted. And by the way, there is a lot of things that needs to be considered here. For example, how many cores do I want? So if I'm scaling very good linearly, I can take like a machine with 64 cores. But if you take a 64-core machine and for some reason it's failing, then you lost 64 cores of power. So I think the magic thing, we at the end we took like quad cores because it was slightly cheaper than 8 cores, but we still wanted to use a smaller rendering units. Another thing is that Wix also have like apps installed in it. So we have a lot of microservices. Those microservices have their own APIs. They write their own components. So when you render the client, the client, once it's renders stuff, it's accessing services inside of the DC and asking for, let's say if it has an e-commerce store, it's asking for the products and etc. So when we moved it to the server, we realized that the server was calling those services from the outside. So the first thing, the simplest, I don't know if it was simple, we created this. Remember that the code has to run both on the client and on the server. So we created this buffer saying an HTTP client, and we inject a different one on the server. So to do that, if those calls are very, very expensive, now we can just rewrite those requests. So if a client is asking for e-commerce, we, on the client side, will use the same URL, but on the server, we rewriting it to use internal resources. Those, like for example, the difference between the access on going through the outside of the data center and going inside it was, I think, 150 milliseconds against 10. So those calls were very, very expensive. Another thing is that every site has user data in it. How the site looks, it's JSON, and we store it on S3, Amazon S3. But we also CDN it. It was very simple on the client side. We just CDN that data, and everything runs smoothly. But when we started with the server, we had to download it from S3, and this was, I think, the biggest surprise I had. Downloading stuff from inside Amazon to its file storage got very bad performance, and not even like they weren't very consistent. I was using internal resources, and still I got to the point where it was 70 milliseconds, and I think it was the best thing. And also, it doesn't matter if after 5 requests it gets to 70, but it starts at 350, because the site renders usually once or twice every couple of minutes. So if they have this cache in place or whatever that fixes it, it doesn't really help me. I want the first request to be fast. So I tried using different URLs. I tried HTTP2, but for some reason S3 didn't support HTTP2 back in the day. And at the end, the solution was very simple. We just put some Nginx cache in the middle, and we dropped it to, I think, like 20 millis. Now I'm stating numbers here, like 50 or 70, but accessing our service that also takes something from the database is in the single digits of like accessing. So if I'm retrieving a product from my service that access another database from the outside, it takes me 4 milliseconds. When I need to just download a JSON file and it's like 70 millis, it's very substantial. And remember, the longer it takes, the more server you need. So those decreases are very important. The second most important thing, like when you build a service like this, or when you're replacing something, you don't want to change the way people work. We had a lot of talks about developer velocity, and we didn't want to burden them. We didn't want to, like, for example, if now to deploy a client version if it was a day or a week, and we'll tell them, okay, now you have to do it, and it will take you a month. That wasn't acceptable. So everything had to be, and every service that the client folks we used to get, we couldn't hurt that as well. It's like if someone is getting a version dynamically, and you tell him, okay, but now you can't do that, and go like, no, I'm using this. This is an important feature in the development process and in the development pipeline. We can't hurt this. So the first thing was actually the flexible client version. When we had client-side render, QA was testing like a specific version before deploying it to production. Also, the client and the server pipeline were different. So when you deploy stuff on the client, it's automatically updated, and they don't need to talk to anybody on the server. By the way, also developing it and using like client code for the testing, if something was breaking there, or if they had this build queue on the CI, then I would keep waiting till their changes were getting built, and it was impossible to work with. And also, clients really needed a way to allow gradual deployment. They had this mechanism in place that they could say, okay, this client version will only be in Poland. And and once they see that it works in like a couple of countries, then they would open it later on. So how do... and it's very simple in client architecture, because client, now it's just a URL, so you just switch the version. You could actually even do it in code, in client code, saying, okay, the version now is not 1.1, it's 1.2. It's very, very simple to implement when you work in client-side render. But on the server, client code is now a dependency. And when it's a dependency, it's really problematic. Like, if we continue, like if we said, okay, so now we have client in place, and it's a server dependency, then it would change the way that people work, because they couldn't do all of the features that they had, and they only had one version in place. So now they want to test a new version, they have to deploy the server. And deploying the server, it doesn't mean that they deploy it to one server, it deploys it to like 100 servers. So... And one of the services, this is actually a pain that I see in one of the services that we have right now in production, is that for every change that we want to introduce to a dependency, we have to deploy their server. So this is, you have like now 100 people from not from your team that require you to deploy your server. And if you're not ready to deploy right now, if you want to do something big, they'll say like, okay, I have to deploy it right now. So how can we fix stuff like that? And the way that we found, it was very simple. Like right now, Node has require in it, and require works very, very simple. It's basically going through the path and just looking for that specific dependency. And it starts at like a very deep level, and then it goes one level below, another level below, another level below, until it finds its dependency. And if it gets to / to root, then that's it. It doesn't find a dependency, and it fails. So this was one of the hacks that we could use with Node to actually make things work. So what we did is, it's a little bit more complex than I'm presenting, but we had system folks just deploying the client versions onto the disk to our server. And now all we needed to do to load the version is just going to a specific path and look for that version. So, and again, now the client is, again, a configuration issue. So for every deploy the client does, even before it does that, system will deploy all of the client code to the servers. And when we change the configured version to the new configured version, then we have the newer version installed on the server. This is one of the things that really helped us moving on. And by the way, we also did the same thing on the testing environment. The testing environment was actually downloading the client code dynamically, and this was actually freeing our build pipeline. So now when we're starting to build stuff, we don't have to wait for their build. Like, we're taking the latest version that was acceptable to our case. We could play with it a little bit, but our build pipeline was not even affected by it. And I think once we got everything rendering and everything working, I think the best thing, even if you're considering any type of server-side rendering, use chunked responses, because rendering now takes longer. And if it takes longer, then it takes some time for the client to work. So the client is actually idle and waiting till it gets everything, and then it works. So what we implemented is just working with sending the header, sending the beginning of the page, waiting for the render, and then store it and then send it back to the client. This allows us to and the browser is working great with that, because the browser, once it gets the first chunk, with the header. It starts downloading scripts, resources. It starts actually to load them, to some of them into the memory. And when the client gets the HTML or the data that we rendered, the end of the page, then everything is ready to work. So this is one of the things that everybody needs to consider if you're thinking about every server-side rendering. And it also gave us a very once we did that, I thought it would very benefit desktop and not client. But apparently it changed a lot of things. Like, for example, browsers throttle requests. So you would think that you get a page and the browser would just download everything parallelly, but it doesn't happen. Browsers takes like 5 resources at a time, or even less, or even more, and it changes and you cannot control it. So one of the effects that we noticed is that once we did that, the page itself would load a lot faster. So when he got to the part where he got the HTML and the other resources, the download pipeline was empty, and it was willing to get and download more and more stuff. So this was something that we didn't anticipate that it would change, like it would affect the data, so the rendering so fast, so substantially, and also. It was built for desktop and not for mobile, because I thought mobile devices wouldn't be that eager, because mobile devices think about radio and think about battery, so I thought mobile devices would just ignore it. But apparently it changed a lot of things inside of the mobile devices. It also improved a lot. I'm talking even like 30 or 40% sometimes. And how it looks right now is that the first chunk is we're rendering stuff, but remember, we have a JVM system on the way, so we had to proxy that first chunk and then proxy the other response. So the first request would get to the server, we'll get to the renderer. Once we got to the renderer, we return the first chunk. Once we got the request, so it would be almost immediately. And then we'll do the other rendering on the server, and then return it to the client. Once we return that to the client, it was when the site gets to be visible. Then we re-render, and then the site is fully functional and not like before. And the third point is you don't want to break anything. Like I said. During the tests that I did for this feature, during the performance test, I had this one thing that I was just testing a few scripts, and once we were using a specific library, and that specific library was limiting the request to 15 megabytes, so or even less, I'm not sure. And anyway. Once the node got like an out-of-buffer access, it would just shut down the process. So I ran this 20 recalls or something like that. Back in when I developed it, I think I had like 4 instances, and the entire cluster was down. And I didn't even notice it because I got alerts from like other automation stuff that I got, and I didn't even run a substantial load, but apparently it killed everything. So we didn't want to get to this case where we deploy a service. Every time you want to deploy something new, you want to reduce the fear that people have. And the way that we did that is that we had fallbacks on every level. It's like we wanted to first of all to be able to release that. Let me think of an example. But every time some developer comes to me and he goes like, we have to release it, and once we release it, we know that it's working, and it's all or nothing. It's like the biggest mistake that it's never like this. It's never you have to switch everything from one point to another, and we invested a lot of time and effort make stuff gradually deploy. So in order for us to be able to deliver it, like imagine you coming to your boss and saying, okay, so we're going to run it now, but we might have a downtime. Nobody would allow you to open that switch. So the first thing that we did is that we analyzed the sites before we sending them to the server-side render, and we were able to, before sending the request, to understand what the site is built. So if the site has a specific component that doesn't support server-side rendering, we're automatically serving it the client-side version. So this allowed us to actually distinguish and gradually deploy stuff. And this was very important for us to be able to deliver this to production. And another thing is, and this is probably the most important thing, is that we had fallbacks on every area. So first of all, what would the user experience when he's trying to access something that was faulty? Usually, he would get the request, and then we would fall back to client side. So he will try to render it, fails, and then just continue with the client side version. This would cause the site to load a little bit slower. And if it would load a little bit slower, but the site would again be visible, then we were safe. And we had to do it in every part of the way. So first of all would be inside of the node server. The node server was sending a request to the other process. Once, if the request was timing out, if an error would pop up, the fallback would automatically be rendered inside of the node server and return to the client. So the client would wait till the request would fail and still client-side render, and everything works as expected. Another fallback would be on the JVM machine. The JVM machine would trigger a call to the node server, and once it wouldn't get a response or get an error or get a timeout, then it automatically fall back to the client on that level. And we even actually implemented a fallback in the client code. So the client code would get the head, and if it wouldn't get after a specific amount of time the rest of the body, it would fall back again to the client side. So by implementing those kind of things, it actually gave a lot of confidence to everybody who wanted to see this project succeed. Because now you run like traffic for 20 minutes. You see like weird stuff that client do, but you still understand that everybody is still getting the site that they're asking. So there is no threat, there is no danger in anything. And I think I moved too fast on this presentation, but there are a lot of things that I forgot to mention, or I thought I wouldn't have time. I see that I have like maybe 16 more minutes, but one of the things that I didn't mention here is the effort that we had on the system side. Moving to like this solution, at Wix we didn't have this amount of servers that we need to maintain, so we had a lot of things that we needed to test. So our system crew had to see, for example, what it is to deploy 50 or 100 or 200 or 500 servers, because we didn't have to do it right now. So a configuration change that would restart the server, what would that take? Would it take 5 minutes? Would it take 50 minutes? Would it take 3 hours? And then if we're deploying something that is faulty, how long will it take to roll back? So we had to do a lot of DevOps changes in order to make this work. One of the things that I didn't mention also is spot instances. Amazon supports spot instances because I think we had an estimation at first when we just started it, and we had this estimation that it would cost about like $1 million just for the servers for I don't know how long. My reaction to that was, well, somebody got to spend that money. But with spot instances, we were able to reduce the cost to, I think, like a quarter of what they estimated. I don't know the exact numbers because, well, I don't care about the money. I just care about the software. And And today, we're actually opening server-side rendering to desktop, and I think it's fully open to desktop, and it's also open. We're moving all the SEO traffic to it as well. And to that, I can accept questions if you want to know about anything I mentioned. Sure. That's an excellent question. At first, we have our own internal RPC system, but it doesn't support streaming. So we tested a few solutions. One of them was trying to use gRPC with that, but I wasn't supporting streaming as well. So at the end, we built, like I said, we built a proxy, but basically we're talking with REST. So REST was used there, and once we got the first chunk, we would move it to the next hop, and this is how we did the communication. Is that? So we have some custom code there that does basically proxying of HTTP requests across our data center, and it moves through a couple of servers on the way. And by the way, this specific task that we wanted to do, we weren't even sure it was possible, because we have our servers. Between each server, we have Nginx servers that do the load balancing between the service. So, and we have 2 JVM services on the way. So now, once Node is answering the first chunk, it moves through Nginx and then one JVM server and another Nginx and another JVM service and another Nginx, I think, and then it gets to the client. And apparently it worked. The testing for it was crazy, though. A template for what? Yeah, the VM itself is it has its conditions in it, but one template. Yeah. Yes. Differences in which numbers? There were a lot of numbers there. How long it takes to render it on the... So just to be clear, we had to process all the traffic anyway. So, but... to render instead of like the VM in Java, it was like 10 times more slower. The JVM, and I wasn't even testing substantial amount of code. This when I tested performance on JVM JavaScript engine, I just tested like a very simple thing, and it took like 10 times more time. And I wasn't even loading all of the client there. It's like I had this. During research, I was trying to see if it's possible for services, our JVM services, to move to server-side rendering without a front-end server, and it wasn't very promising. So, like, we made it work, but it's not thread safe, and it was very. You're better off using Node. And by the way, Node, like one of the surprises that we had, moving from versions of Node would improve performance. So we started with Node 7. The move to Node 8, I think we had like 30% more performance on it, like better performance on it. And just from moving from one version to another. So I don't see any alternative. It's not the mathematics. It's more. Think about it like this: you have JavaScript code running there, and VMs really improve stuff once they run it more than once. So the difference now in server and client rendering, client would render it only like once, but the server gets like 1,000 requests to a specific VM, and then the VM node itself would improve, like the JavaScript engine would improve and say, okay, this one is always happening in one spot, so it optimizes that call. So those kind of things really help performance. Well, I do. Any more questions? Yeah, with Nash, I'm sorry, I forgot the JavaScript engine. I used the latest one. Nash one is the latest one, and it was still slow. JVM, yeah. I'm using the regular one, Oracle one, the hotspot. But again, using Node and using Java would actually, I had to write a lot of custom code to make Java work with it. And right now, when we are in this world where you have people working also in Node and also in Go and also in a lot of languages, everything the only thing that is important is the way you talk between servers. And once you have that in place between all of the technologies, it's basically you can choose whatever you want, whatever is the right tool for the job. It's like those flame wars between Java and C, and it doesn't matter. Every language is a set of tools, and that set of tools is very good for one thing, but very bad for another. So when you consider options, for example, in this case, Node doesn't have competition. It's like if you would have to render something, and instead of 50 millis, it would take you, I don't know, 500 millis. Would you do it because you're working with a specific technology? You're better off taking something that was built on top of it.
So to clarify, JVM is nothing more using only for the database communication. Yeah? So for the backend database communication, what is the purpose of the JVM?
Yes, we are at Wix. We're working in Scala, and most of the microservices are written in. You know, as a backend, I was more biased toward using Java, so I was trying this, but it failed miserably. But there are services that right now, and I had to write in JavaScript, which was very painful for me at first, but I got adjusted to it. And I would say that you can do amazing stuff with JavaScript, but JavaScript as a language, to my opinion at least, is very good on a smaller scale. Once you get to a specific code size, it gets very, very difficult, and people can do crazy stuff on JavaScript. Crazy. It's like the amount of troubles that people can cause, it's like one of the things that we invested was we were afraid of memory leaks and people doing like crazy hiding, like accessing to DOM or whatever. So I actually spent a week just to write a code that runs a specific something on a specific code, run like 1,000 calls and detects memory leaks. And at the end, we didn't use that. We didn't use that because we were too paranoid of what client people would do. But again, if you'll have to build like Node and JavaScript it's great for I/O. So if you have a service right now that all it does is just like calling this server, and calling this server, and merge the result and returns it back, I don't see any reason why not to use Node for that. But if your server gets to have a lot more logic, and again, client code, JavaScript is advancing, and now with ES6, it looks fairly okay. You can still do crazy stuff, but you can do also crazy stuff in Scala, and we educate people not to do them. Any more questions? Sure. The amount of servers we had before, compared to, I have actually had legal talking to me about this presentation, which I hate legal. So I can't say like exact numbers, but I can say it's about like 10 or even 20 times more computers than we needed. So it was a very substantial. I think it like almost doubled the amount like of number of servers we had in our DC. Almost like for all of the services and just the rendering one, I think it was the same amount. And it was, which was more funny is that when we gave like estimation of big number of servers, like 200, 300, I would think that management would be angry at me, but they actually liked it. They had presentations saying like, oh, look, we need now like 300 servers or 500 servers. So go figure. Any more questions? Sure. So, first of all, yes, it's the same code. There is only one difference. I'm sorry. The only difference was the code that was handling remote calls. So I mentioned it. Maybe I didn't spend too much time on that point. Is when an HTTP request was going out, it was using our on the client. It has one version, and we injected it from the other side. So this was the only difference. And no, there shouldn't be any difference because, like I said, the code, we don't render everything on the server. It's like you render the first render comes from Node, and you get a prepared HTML. But like other activities on the site later on, if someone switches like a page inside of it or does something, it still does another React render. Also, when you get a response, you get just an HTML. You have to hook it up into events and starts, all kind of things in the client. So basically, you still do a client-side render, but it doesn't. It only happens after the users see the site, so it doesn't matter. Do that from Java? Oh, JSPs, I haven't heard about them for a while. I thought they're dead. No, template. Yeah, but it doesn't just render stuff. It's not like Velocity or other template engines. Template engines in JVM world, usually you have just one template and just you replace strings inside of it. Maybe you have this logic doing a for loop. But in JavaScript, you actually have code that generates it. So you run actual code that at the end of it, it would generate a specific HTML. So it's not a template. It's basically code. I hope that client people won't hear you, but they do a lot more complex stuff. They have a lot more logic there that handles that. As a server guy, I would think that you might be able to do that as well, but now it's more complex than that. And I'm almost out of time, so one more question or we'll conclude. Okay, so thank you for staying till the end of the day and listening to me. Bye.